I'm going to show you how to evaluate this integral. This problem is from quiz number 2 in Advanced Engineering Mathematics. So it says here that you are to evaluate the integral of t raised to 4 times e raised to negative times the quantity s plus 1 times t dt with limits from 0 to positive infinity. There are two ways for you to evaluate this integral. You can integrate using integration by parts and applying the limits with respect to t from 0 to positive infinity. And the second method is the fastest method or the fastest way. So I'll be showing it to you now. Okay, so recall that the Laplace transform of f of t is equal to, by definition, the integral of e raised to minus st times f of t dt with limits from 0 to positive infinity. Now we are going to write this in a form of Laplace or using the Laplace operator. So Laplace of, we have t raised to 4 e raised to minus s, distribute this one, times t, so minus st times e raised to negative t dt with limits from 0 to positive infinity. Now, let me just continue in writing it in the form. So t raised 4 times this one. We can write this given integral into or using the Laplace operator. Thus, we have this result, Laplace of t raised to 4 times e raised to negative t. So it's okay if you have done integration, since Laplace is an integral transform, or you simply do this method. Now, as you can see, inside this braces, you have functions t raised to 4 times e raised to minus st. So this is first shifting property. Applying it, we have, let me just write the formula for your guide again. So the Laplace transform of t raised to n times e raised to a times t is equal to n factorial over s minus a raised to n plus 1. So following this formula, we have this result, n factorial, so n is 4, so you write 4 factorial over s, a is negative 1, so minus negative 1, so that's s plus 1, raised to 4 plus 1, we have 5. And you should express 4 factorial, evaluate this one. This is equal to 24 over s plus 1 raised to 5. Now this is your final answer. So if you have chosen the long method to evaluate this integral, it's okay. Make sure that you have applied the limits properly. So that's all.